And I'm doing Unit 2, Day 5, which is all about finding the distance between 2 points. So by the end of this lesson, you'll be able to find the distance between 2 points by substituting values into the formula. Today we're going to do a little review to kind of help prepare us. So we're going to start with number 1, reviewing how to simplify this. To simplify with square roots, you want to simplify everything that is under the radical first. And then the final thing that you're going to do is the square root. So we're simplifying everything inside first, and we're going to follow PEMDAS. So what that means is we need to do these squareds before we subtract. So this is going to be some big numbers here. 13 squared is going to be 169. Minus 12 squared is 144. That is all still under a radical. So that's what we do first. Now we fully simplify what's under the radical first before we square root things. So we're going to actually do this part before the square root. 169 minus 144 is going to be 25. And then the final thing we do is square root this. Square root means what multiplies by itself to give us 25, and that answer is 5. You can also use the button on the calculator to help you with that. All right, next one, let's follow PEMDAS. Let's do what's inside the parentheses first. Double negative means add. So this will be 5 plus 3, which is 8. And then 8 squared is 64. All right, this one's really similar to the first one we did. We're going to square each first. Negative squared is a positive, since it's in parentheses. So this will be positive 25. If you're unsure, type it into the calculator exactly as is, parentheses included. Plus 7 squared is 49. And then we're going to fully simplify under the radical. So we don't square root these, we add them together. 25 plus 49 is 74. That is not a perfect square. So the directions didn't say if we wanted exact answers or decimals. I'm just going to do a decimal for this one. So I'll type in into my calculator square root of 74, and I get about, squiggly equal sign means about, 8.6. And then the last one I'm going to review again, follow PEMDAS. So do what's inside the parentheses first. 4 minus 9 is negative 5 squared. Keep the parentheses on there. Negative 5 squared means negative 5 times negative 5, which is positive 25. All right, so today we're going to be using the distance formula to find the distance between 2 points. I'm going to show basically 2 kind of trains of thought or 2 ways you can think about this. If you are someone who loves a formula and you love to just plug and chug, go for it. You can use this formula and it'll give you distance every time. For some people, we might want to kind of think about this a little bit more like conceptually, and so I'll show both ways. Some of you might find one way easier than the other. So find the distance of the segment using the following graphs. So we're going to start with number 5. I'm going to do this, like I said, I'm going to do it 2 ways. I'm going to do the formula first, and then I'm going to show the other way that I'm talking about in a minute. So first thing I do is I label the coordinate points. This is the coordinate point negative 3, 1. And this is the coordinate point 4, no, not 4. We go left to right first, so this is 1, negative 4. If I'm using the formula, I need to label this. This will be x, y, x, y. This will be x1, y1. This will be 2, 2. When I'm labeling the points, it's always x first, then y, and then I just pick one of my points to be my first point and the other one to be the second point. All right, and then I'm going to plug into the formula. So according to this formula, it's d equals, and then one giant square root, and then it'll be in parentheses x2, which is 1, minus x1, which is negative 3. I need to make sure, this is really important, I need to make sure that I put a minus because the formula has a minus, and I put another minus because this is -3. So I have minus -3. And then the formula has a squared here, so I put a squared, plus, and then I do y2, which would be -4, minus, because the formula has a minus in it, and then -1, which is 1. And then I square it. And then I simplify inside the parentheses first. So this is going to be plus, because the double negative. 1 plus 3 is 4. So I'm just going to rewrite this as 4 squared. And then -4 minus 1 is -5 squared. 4 squared is 16. Plus 5 squared is 25. And then just like the simplifying we did above, I'm going to add these together first and then square root it. So 16 plus 25 is 41. And then I'm just going to type this in the calculator. Square root of 41 is about 6.4. All right, so that is what you're going to do if you would prefer to just plug directly into the formula every time. So the big key things here are be really, really careful about negatives. Make sure you're copying down the formula exactly. Now I'm going to show an alternative method for how we can do this without using the formula. And that is going to be using Pythagorean theorem. So what that's going to look like is we are going to create a triangle from our line segment. So from the endpoint, I'm going to go straight down and straight to the side to create a right triangle from each of the endpoints. And then I'm just going to count how far I went down. So from this line, this endpoint, I went down 1, 2, 3, 4, 5. And I count how far I went over. 1, 2, 3, 4. So I went over 4. All right. And then from there, those are the values that we're going to square in the distance formula. So it's going to be 5 squared plus 4 squared that we're using in the formula to find the hypotenuse, or this long side of the triangle. So this number squared plus this number squared. 5 squared is 25 plus 4 squared is 16. 16 plus 25 is 41. And then square root of 41 is about 6.4. All right, next one. This one should be easier to count the distance because I can actually just count it. This is going horizontally. I can easily count the distance from here to here. This goes 1, 2, 3, 4, 5, 6. So this answer should be 6. To confirm this answer, I'm going to plug it into the formula just to give us a little more practice with the formula. But our answer in the end should be 6 if we do everything correctly. So I'm going to label the coordinate points. This is -4, 2. And this is 2, 2. This will be xy, xy, 1, 2. And then I plug into the formula. This should be x, under the square root, should be x2, which is 2, minus x1, which is -4, squared, plus y2 minus y1. So this will just be 2 minus 2 squared. All right, we'll simplify over here first. This will be a plus. 2 plus 4 is 6 squared. Plus 2 minus 2 is 0 squared. 0 squared is just going to be 0. So this part just goes away. This will just be 6 squared, which is 36. And then the square root of 36 is 6. So our answer here should be 6. All right. On the next one, I'm going to show both ways that we talked about. I'm going to do the triangle way first, and then I'll confirm with plugging into the distance formula. So I'm going to create a triangle. I can either create the triangle this way, or I can create the triangle this way. And I basically just count how far apart the x values are and how far apart the y values are. So the x values are 1, 2, 3, 4, 5, 6, 7, 8, 9. And then the y values are 1, 2, 3, 4. So what that means is the difference between the x values should be 9. And then the distance between the y values, so the difference between the y values should be 4. So when we plug into the formula, it's just going to be 9 squared plus 4 squared under the radical. 9 squared is 81. 4 squared is 16. Let me use my calculator. 81 plus 16 is 97. Square root of 97 is going to be about 9.8. So the distance of that segment is about 9.8. All right, if we were doing the same problem using the formula, we would need to label these points. So this would be 5, 3 is this coordinate point right here. And this is -4, -1. I'll call this x1, y1. This will be x2, y2, and then we plug into the formula. So x2 would be 5 minus x1 would be -4, so double negative there. And then y2 minus y1 would be 3 minus -3. Or sorry, 3 minus -1, sorry. Squared. Double negatives will become plus. So this is going to be 9 squared. And this is going to be 4 squared. Which is exactly what we had the other way we did this. 9 squared is 81. 4 squared is 16. Add those together, we get square root of 97, which is about 9.8. So if you want to plug fully into the formula, you can. But an alternative to plugging fully into the formula is recognizing that x2 minus x1 is just the distance between the x values, and y2 minus y1 is just the distance between the y values. So if we want to try to do this without the formula, we want to look at the distance between the y values. How far apart, or sorry, x values, how far apart are 3 and -3? If you have a number line, 1, 2, 3, 1, 2, 3, this is -3, this would be 0. How far apart are those? They are 6 apart from each other. Let me square that. And then same thing with the y's. We want to see how far apart are the y values. How far apart are 8 and 13? The way we find that is by subtracting them. 13 minus 8, sorry, 5 and 13. 5 and 13, how far apart are they? 13 minus 5 is 8. They are 8 apart from each other. 6 squared is 36. 8 squared is 64. Add those together, we get 100. Square root of 100 is 10. Now, this might be easier to do when you have a picture, because you can draw your triangle. It makes it a little easier to do. So for a problem like this, if you want to fully plug into the distance formula, that's totally reasonable. Go for it. I'll write the distance formula right here. It's x2 minus x1 squared plus y2 minus y1 squared. I'll call this xy, xy, 1, 2, and then we'll plug into the formula. x2 is going to be negative 3 minus x1, which is 3 squared, plus y2, which is 13, minus y1, which is 5 squared. Negative 3 minus 3 is negative 6 squared, plus 3 minus 5 is 8 squared. Negative 6 squared becomes positive 36 because it's in parentheses, plus 8 squared is 64. Add those together, we get square root of 100, which is 10. All right, and then the final one, x1, x1, y1, x2, y2. We'll plug into the formula. x2 is going to be 0 minus x1, which is negative 4 squared, plus y2, which is 15, minus negative 7 squared. This becomes positive. This will be 4 squared. This will be 22 squared. 4 squared is 16. 22 squared is 484. Add those together, we get 500. And then square root of 500 is about 22.36. All right. It does get to be a little bit complicated, so please ask your teacher if you need help with any of this.